Special case before we get into this problem. So 2 and 3 are the first two consecutive primes. Notice that 2 plus 3 is equal to 5. All right, and that's never equal to twice any prime, right? And that's 2p for all primes, right? Okay. That even prime is always a problem. You always got to seem like you have to handle that at the beginning. But now let's go ahead and assume that p and q are consecutive primes and that they're odd. I didn't mention that. Now we'll suppose that p plus q is double a prime. Okay, in other words, we're supposing the opposite of what we're trying to prove right here. All right. Now this doesn't really depend much on primality. Another way to write this is p plus q over 2 is equal to n. That makes n the arithmetic mean of p plus q, which means it's right in the middle. Now this statement over here is very easy to prove. It's just a one-step proof basically. So what we would have right here, if this statement were true, we would have that p is strictly less than n is strictly less than q. All right, now remember y'all, p and q are consecutive odd primes, and consecutive odd primes differ by 2 or more. Just, look at 3 and 5, 7 and 11. And so this is clearly a contradiction. P prime, n prime, q prime. So this would contradict the consecutive part right here. In other words, that means p and q not consecutive. Okay, so this is really a strange proof. It appeared as the very last problem in Vanden Eynden's textbook on prime factorization, the section there. Not consecutive. Consecutive, right? Okay, so that completes the proof. It contradicts the fact that p and q are consecutive. So we're QED time. And again, folks, I'm not sure if this would be true of all odd numbers too, right? Or maybe all even numbers even. So you see, this truth right here is a statement for all real numbers, for all A, B, a member of the real number system. Okay, so it has nothing to do with whether or not you're even dealing with integers. It's just always a fact. If A is less than B, this is always true. So again, I'm not quite sure about this problem in terms of if it was intended, if it's a mistake. It's true, but so what, Okay, folks, I hope you enjoyed.